In this video, we're going to talk about the seasons and we're also going to talk about solar angle because solar angle is very important and it's really the first step into understanding how meteorology works. So in this video, we're going to address two questions. We're going to talk about why different latitudes receive different amounts of solar energy and why does that amount of solar energy that changes produce different seasons. And so what you already most likely know about the Earth is that it takes 24 hours for the Earth to make one rotation on its axis, which is 24 hours. It also takes 1 year for the Earth to make one revolution around the Sun. And so on any given day, the Sun is about 150 million kilometers from the Sun. And so what is important to note is that the Earth travels in an elliptical orbit around the Sun. So it's not always a fixed number. And so it varies. And so during the northern hemispheric summer, the Earth is actually around 152 million kilometers away from the Sun. Now, during northern hemispheric winter, the Earth is actually closest to the Sun, which is about 147 million kilometers away. But for us who live in the northern hemisphere, we know that it's warmest in June, July, and August, which would be considered the summer months, and it's coldest in December, January, and February, which would be the winter months. And so it kind of seems counterintuitive that when we are closest to the Sun, us in the northern hemisphere, we experience our coldest weather and vice versa. And so when we make these two passes, we actually call them either aphelion, which is when we're the furthest from the Sun, and we are closest during perihelion, which occurs in January. And so this is because the Earth travels in an elliptical orbit and it's not a perfect circle. And so why is it that when we're closest to the Sun, we're actually coldest, and when we're furthest from the Sun, we're actually the warmest? And it actually does not have to do with anything in regards to the distance to the Sun. It really just comes down to the tilt of the Earth's axis. And so the Earth is tilted at a 23.5-degree angle. And so it really just determines, is the Earth tilted towards the Sun or away from the Sun? And that is what dictates the seasons. And so here you can see in this diagram, during our summer solstice in the northern hemisphere, we know that the Earth is tilted towards the Sun. And oppositely, during the winter solstice in the northern hemisphere, the Earth is tilted away from the Sun. So the amount of distance that these sun's rays have to travel is actually less during our summer solstice because the Earth is tilted closer to the Sun, and it's the other way around during our winter months. Now, during the spring months and the fall months, this is when the Sun is concentrated directly over the equator, and so that means that the Earth is actually receiving the same amount of solar energy throughout the entire globe. And so what's actually interesting to note is that during the summer months, or during the first day of summer, which happens around June 21st to June 22nd, the Sun is actually the highest in the sky. Now, the maximum solar angle that you get depends on where you are latitudinally wise, and the shortest day of the year occurs during the winter months, or the winter solstice, which happens right around June 21st to June 22nd. And again, depending on where you are, this is when the Sun is the lowest in the sky. And that's why during the winter solstice, the Sun, or the amount of daylight that we get, is actually the least. And when we have the most sunlight is during the summer months. Now, during the equinoxes, either the spring equinox or the fall equinox, the Sun angle is right between the extreme high and the extreme low. So when it comes to determining temperature, it's really about the insolation, or how much solar energy is actually being received at the Earth's surface. So let's take 3 different locations. Let's take a tropical location, let's say somewhere in the Caribbean. Let's take a place in the mid-latitudes, let's say anywhere in the United States. And then let's take a polar location, let's say Santa's house. And what you notice between all 3 of these is that the amount of solar radiation that each location gets or does not get. So for a Caribbean location, we know that you could go during any time of the year and it's always going to be sunny, relatively warm. There is no snow. There's no need for a winter jacket. They experience the same temperature throughout most of the year. They have they have a very small temperature range. Now you go to the mid latitudes, let's say anywhere, let's just pick Pittsburgh, Pennsylvania. Pittsburgh has hot summers. It also has cold winters. Pittsburgh sees snow. It also sees heat waves. So it sees much greater temperature swings depending on what season it is. And a polar location, we know that if you think of Alaska, you think of snow, you think of cold, or if you think of the North Pole, you think of snow and ice and cold. And that's technically what is thought of in regards to a polar location. So the main difference between the three is how much solar energy is actually distributed per unit area. And so what does that mean? So if you notice in the Caribbean location, the sun's energy is concentrated directly overhead throughout most of the year. And that means that when the sun is directly overhead, that it's getting more direct solar radiation. So when that happens, that means that that location technically is or experiences a warmer climate. When you go to the mid-latitude location, you see that the sun angle is actually distributed over a more tilted area. And so you can say that the average solar angle is about 45 degrees, whereas the tropical location, the average angle is right around 90 degrees. And so what does this mean in comparison to a polar location is that the more distance or the greater distance that the sun's rays have to travel per square area, meaning to say that the greater distance that the sun's rays have to travel over the land, the colder that it will be. And so when the sun's more directly overhead, we have warmer climates. When the sun's energy is distributed over a greater area, it's actually colder. And so this is what is the main difference between a tropical location and a polar location. So to kind of make a very basic example of this, if you've ever been to an amusement park or any kind of public place where mass quantities of food is served and they keep that food hot via heat lamps, well, why are the heat lamps directed right over the food and it's not tilted at an angle? Well, have you ever heard of the saying, well, the shortest distance between 2 points is a straight line? Well, that's very true. In this case, the distance between the heat lamps and the food is a straight line. So that means the electromagnetic radiation that these bright light bulbs give off, that radiation has less distance to travel when the heat lamps are directly over the food. If the heat lamps were ever tilted on the side, that means that the electromagnetic radiation from the heat lamps would actually take longer and actually get distributed, and by the time they heat the food or even reached the food, they would be much less effective because that they have a greater distance to travel. So when we actually talk about solar energy, it's really the same idea. And so when energy or the sun's energy is spread over a larger area, that means that the colder or the less solar radiation that they get, and therefore the colder they are. When you look at a tropical location, the sun's energy is primarily directly above. So those are the main differences between tropical locations and mid-latitude locations and polar locations, and that's why the seasons are the way they are.